Yeah, good morning. Thanks for joining us. My name is Will Eldridge. I'm an aquatic habitat biologist with the Vermont Fish and Wildlife Department. This talk is in conjunction with Jens Hilke from the conservation planner, also with the Fish and Wildlife Department. Today I'm going to be talking about resilient rivers, good for fish and for people. So this is a talk motivated by the events of last year, the flooding that just happened. But before I get started, there's a few things that logistics that Jens asked me to cover. So let's see, make sure I can do this. So first, this talk is in Microsoft Teams, and so a couple things. Please keep yourself muted to cut down on background noise. As you've heard, this talk is being recorded, so it will be available on the Fish and Wildlife Department website when it's done. Please introduce yourself by typing your name, town, organization into the chat. Also, if you do have any questions, we ask that you please use the chat function to do that. For those of you not familiar, there's a bar either at the top or the bottom, somewhere on the screen that has that little chat, the bubble icon. That's what you use for chat. And then we're going to pause a few times throughout the presentation to respond to questions. All right, and those will be through the chat function. All right, and just introduction. So the Fish and Wildlife Department, our mission is to conserve the fish, wildlife, plants, and their habitats for the people of Vermont. And this is important just so that everybody's clear. When I do this work, when I talk, I'm really thinking like a fish or what, like an animal or a plant. So our job really is to think what is the best for the fish or the wildlife or and their habitats. So anyway, just so we're all clear. And also the Community Wildlife Program, this is a program that Jens runs. This also offers technical support to municipalities and others interested in what they can do to protect and restore habitat for wildlife. Jens, I'm sorry. Do you want to add anything about the Community Wildlife Program at this point? Okay, great.
No, that's great. Thanks, Will.
Yeah, you're welcome. All right. Okay, and so, all right, jumping into the talk. So the agenda today, first I'm going to give a little background about the aquatic habitat and really the issues that we're dealing with regarding flooding. And then I'm going to talk about ways that we're trying to address that and both improve aquatic habitat as well as flood resiliency by addressing culverts and aquatic organism passage, as well as riparian habitat. Riparian is that zone between the terrestrial and the aquatic. It's that kind of interface. And then in-stream, so things that we can do in-stream to address flood resiliency and aquatic habitat. All right. And then throughout the talk, we're gonna take these breaks, and so we're not gonna do one right now, but just you'll see this little bubble pop up. That's when we're gonna do our breaks, and those will come between the sessions. So jumping into it, so July 2023 was made Vermonters aware of the risks that we face with climate change and particularly flooding. It was devastating throughout the state, and there was a lot of anyway. It kind of opened our eyes to the reality that we're facing. We just had Tropical Storm Irene in 2011, and then this event in 2023. These huge events are occurring more frequently than we expected. We anticipate that they'll be occurring. These things could occur again in the future. And so how do we learn to live with flooding, recognizing that this is probably the future that we face? And a couple of things. So historically, we've tried to address flooding by really just trying to get water off the landscape, out of our systems as quickly as possible, just get it downstream and try and control flooding that we can. And what we found is that really is not practical or sustainable or effective. And it can actually make problems worse. And I'll introduce some of those problems. But when we talk about flooding, there's really three different areas, specific impacts that flooding can have. And so this image, this is a farm that was flooded during the July floods. And so this is showing what's called inundation. So this is where that water spills out onto the floodplain and basically floods structures and dwellings and kind of leaves them uninhabitable. The other impact that flooding can have is what's called erosion. And so, this is the unfortunate scene up in Hardwick, where the Lamoille River undermined the banks and destroyed the hotel up there. And then another thing that flooding does is it also it can mobilize materials, so wood and rocks and stuff like that. It can really move material, and this can have devastating impacts on our infrastructure. And here's just another example of what can happen. And so here's a road that where the culvert just got washed out during last year's floods. And so historically and to some extent even today, what we continue to how we respond to floods is really we're just patching things back together. We're recognizing that this is an emergency situation. We need to get roads open. And so we're just, in this case, slapping the old culvert back in, paving it over, and just making sure that people can get through. I recognize going forward that we're, hopefully this isn't going to be the practice, but historically this is what we've done. And this is what a lot of other states continue to do, is they really just put the same infrastructure back and hope for the best, basically. The other thing that we've seen a lot of is, people are concerned about this material getting mobilized, and so they'll actually get in the stream or river with heavy machinery and dredge it out, and then they'll actually build up the banks and basically just create a pipe, a channel, just to keep that water in there, just make it move as quickly as possible. Here's another example of, removing trees from the river. And these are pictures from after Tropical Storm Irene, where people were going in and removing material from the river. And what ends up happening is you end up with situations like this, where it's basically, from a fish perspective, this is not good habitat. This is a type of area where we wouldn't find fish. It's also, because the banks have been built up, it's also holding more water in the channel. And so when we think about, one of the questions I often get is, how are these floods impacting fish? And so there's two different outcomes that can happen. So in situations where we've left the habitat intact, we will see a small decline in the fish numbers, but then within 1 to 3 years, they'll actually recover. And often what we see is that there's actually an increased growth in the fish. You get a lot of terrestrial subsidies, is what we call it, a lot of food, bugs and stuff falling into the river. And those fish that survive are actually doing really well, and we see them actually grow really quickly. And so when habitat's left intact, we see these populations recover pretty quickly. In these altered habitats, where we've channelized the system, removed all the material, removed the habitat, we don't see those populations recover. We see the populations crash, and even after Irene, we haven't seen those populations recover. And to the point that we've actually had to go back into some of these systems and try and restore that habitat. We actually just did a project, ironically, in August of last year. We were trying to do it before, but anyway, it was a post-Irene habitat recovery project that we did in 2023 while dealing with while dealing with that flooding. So anyway, again, point being, we're still recovering from some of these habitat modifications that happened a decade ago. All right, and the other issue is that this flood response can also be detrimental to people. And so what's happened is we've straightened our rivers, we've removed the material, and we've basically created this perception that we've reduced the flood risk. All right, and so we've built in these flood-prone areas, and this is an area, this is actually my neighborhood in Montpelier, and we've straightened the channel and just put houses back in what would have been the floodplain or the river corridor, where the channel would have migrated historically. And the other issue is that we've turned these streams into pipes. By moving that water downstream, what we're doing is we're just increasing the amount of water that's ending up in those downstream communities, making that flood risk greater down there. So there's more water going to those communities, increasing the erosion and inundation risks. And so what I'm here to talk about today is there an alternative strategy, the alternative strategy that we're trying to encourage Vermonters to take to deal with these flood risks? Right, before getting into that, and also why this approach is good for aquatic organisms, fish and other wildlife. And so with that, we'll take our first break, and if there's any questions, I'll be happy to answer them.
Good morning, folks. My name is Dave Maroney with Community Wildlife Program. I'll be popping on during these breaks to read out any questions that you might have. What we'd like to encourage you to do is as well as presenting, place your questions in the chat at any time that you have them, and I'll be able to keep track of them efficiently that way and ask them and collect them, ask them to Will at these breaks. Depending on time, there may be an opportunity for a few folks to come on towards the end to ask a question directly, but we found this is a great efficient way to do that. So if you have any questions at this time, place them in the chat. I see one person is typing, thinking. Otherwise, there'll be plenty more break opportunities as we go on to get these questions to Will. So I'll pause for a brief moment. See, it looks like Tracy may have a question coming in. All right, well, we'll have a chance to come back to that. So let's go back to you, Will. Continue the presentation.
Great, thanks. All right, let me, okay, thank you. Oh, there we go, next up. Okay, so living with flooding, how are we doing it? How do I recommend that municipalities address this? And so there's three specific areas I want to talk about. First is fish-friendly culverts. So designing our stream crossings to be both flood resilient as well as friendly to pass aquatic organisms. And then the next is that riparian zone, that riparian forest. And so that's that transition between the terrestrial and the aquatics. And then in stream, we're looking at how can we leave material, log jams specifically, in streams and increase both flood resiliency and aquatic habitat. And so just kind of the way I see it, the way I see Vermont's approach to dealing with flood resiliency is really what we're trying to do is in areas that we can, where flooding is not going to impact human health or safety, infrastructure, that sort of stuff, allow it to occur. So basically up in mostly in headwater areas, undeveloped areas, basically allow, encourage flooding or allow for flooding in those zones. And try and with the idea being that we're going to reduce the amount of water in it hitting our developed areas. All right, and then so starting, I just want to talk about culverts and things that we're doing to increase flood resiliency as well as aquatic habitat with culverts. And so this is an example of a culvert that failed during the 2023 July flood. Here's another problem that culverts can have. So even if they don't fail, they can become barriers to fish passage. And so this culvert is perched. There's about a 2-foot drop between the culvert and the stream below. And so fish are basically not able to move upstream through it. And what's interesting is these culverts often are not installed with a perch, but this is something that evolves over time. Because the culverts are undersized, they're not able to pass material like rocks and wood. And so that material builds up on the upstream side, and you end up with erosion or degradation on the downstream side. And so this perch kind of evolves over time. And so what we're recommending that folks do, first thing is to size these structures to what's called the bank full width. And so the bank full width, that's it's a hydraulic concept, but basically it's what we take to be the width of the stream when it begins to spill out onto the floodplain. And so that's roughly the 1 to 2 year event, or 1.5 year event. And so what we find is that culverts that are sized to the bank full width are more flood resilient. They're able to pass material, and as well as maintain that aquatic organism passage. The other thing, there's some other things that are included in this, like embedding them so that they have natural stream bottoms throughout. That also helps with passing fish and other organisms. And so we've looked at structures throughout the state, and we've done an assessment of them, looking at their ability to pass fish, so the aquatic organism passage. And so we've looked at about 18,000 structures throughout the state, hired seasonals and other consultants to do these surveys. And, so basically we've covered the entire state, and each of these dots represents an individual structure, and the color corresponds to the aquatic organism passage. Red are structures that are impassable, gray are partially passable, green are fully passable, and it's pretty obvious from this picture that most of our structures are impassable or partially passable. And just looking at that from in a chart form, you can see that only about 6% of our structures are fully passable. Most are reduced passage or offer no aquatic organism passage. Also, when we look at the size of our structures, this is that bank full width relative to the width of the structure relative to the width of the stream. We see that over 50% of our structures are less than 50% of bank full width. And so bank full width, that ratio is one of the key risk factors for failing during a flood. So most of our culverts are at risk of failing during a flood. Now, that being said, after Irene, and actually a little bit before Irene, Vermont adopted standards for bridges and culverts that required them to be sized to the bank full width standard, as well as aquatic organism passage. And so what we did, what I did in the fish division here is we actually went back to some of these structures that have been installed since 2011 and looked at how well we've been achieving these standards. Have we been installing structures that meet that bank full width standard and the aquatic organism passage standard? And we looked at about 200 structures across the state, 215. And just from a fish passage standpoint, what we found is that, before there was only about 6% that were fully passable. Now it's up to about 40% are fully passable. So a huge improvement in that passage standard. There's still a few that fall into the reduced passage and much lower that hit the no passage standard or don't provide aquatic organism passage. And there's a variety of reasons that happens. Often it's due to challenges at the site. Either there's ledge or something like that may make it difficult to embed a structure. But anyway, that's a subject for another day. But basically, the point I just want to make is that we're definitely moving in the right direction from an aquatic organism passage standpoint. And then here are just some examples of what those structures look like. So these are all concrete box structures installed by municipalities. And I want to emphasize that these are structures that municipalities and using their own funding installed, designed and installed up to our standards. And so these are not structures that the state, Fish and Wildlife Department is installing. These are ones that municipalities are doing on their own. And so all these structures are examples that meet our standards and for size as well as for aquatic organism passage. All right, and so here's some examples of aluminum arches or squash culverts, and then round pipes. And so again, all of these are examples of where municipalities have installed structures that we feel meet the standards. So this is happening in Vermont, and it's definitely an improvement. The other important question is, all right, so it's working for aquatic organism passage. How's it doing for flooding? And so after the July 2023 flood, we went out and we assessed about 60 structures around the Montpelier area, which got hit pretty hard. And what we found is that structures that were installed to standards, so structures that were installed since 2011, all of them were intact. We didn't see any signs of the structure, any like material being accumulating or the road being washed out. Now, here's an example where we had an interesting juxtaposition. So we had a replaced culvert upstream and then just downstream. This is on Orange, right off of 302. We had an undersized culvert, one of the old culverts, that completely blew out. And so, this is, to me, like one of those quintessential examples of how sizing our culverts to standards provided that flood resiliency. And so what can municipalities do to address these aquatic organism passage, these culvert issues? And so the first would just be following our stream alteration standards for culvert and bridge repair and replacement. The other is just work with the Department of Environmental Conservation as a stream alteration engineer, and so they can help municipalities with design and permitting related to streams, culverts, and bridges. And then the third is this rivers and roads training and highways and habitats trainings. These are two trainings that offered by Agency of Natural Resources in conjunction with the Agency of Transportation. And I'll talk more about that on the second in a second. And then there's also more information on the Fish and Wildlife Department website about culvert design for aquatic organism passage. And so those trainings, the rivers and roads and highways and habitats, these are multi-day trainings that are really immersive. And so the idea is that we're working with municipalities, road foremen, Agency of Transportation engineers, project managers, and basically introducing them to the concepts of our stream alteration standards and what's called road ecology. And so that's that kind of like wildlife road infrastructure interface. And so these are a combination of classroom presentations as well as some lab exercises. We have what's called a stream table where we can actually simulate a flood and look at how different road infrastructure is impacted. And then we also have some field exercises where we actually go out to different sites and get to see different practices and discuss them. And this is let's see, the next Rivers and Roads training will be in May, and I think there's a Highways and Habitats. There's a Tier 3 happening this spring, and then there's another a 4-day Tier 2 training happening in the fall. And that's something I'll be happy to answer questions about if there are any. And I think with that, yes, we'll break for questions.
All right. Well, we've got 2 comments and questions.
Okay.
So the first one, I've got a question following up on a comment. So Ron in the comments pointed out a particular culvert across State Route Vermont 100 in Hancock, Vermont that likely needs replacement for trout migration. So my follow-up question is can people report instances of culverts that seem like they really need to be replaced or might be a high risk for washing out for flooding or for interrupting habitat?
Yeah, no, that's a really good point. Yeah, definitely. We do work with partners. So we don't have the capacity ourselves in the department to do this, but we work with conservation districts, watershed groups, and others to identify priority structures for aquatic organisms or wildlife connectivity and to try and replace them, either up to standards or with a wildlife shelf, something to provide passage. That being said, these are complicated, expensive projects, and they don't happen right away. We don't have capacity to do a lot of them, but yes, we're definitely interested in identifying those, and as our capacity exists, we will address them.
Great. Okay, so a question from Ken at the Georgia CC. So in Georgia, they have a hydraulic study for an AOP stream.
Okay.
And the question is, do they need any additional engineering beyond an existing hydraulic study?
Yeah. Yeah, I mean, that's definitely a question for the stream alteration engineer. Chris Brunel, I think, would be the engineer up in Georgia. But yeah, I mean, I'll just leave it at that. I'm not the expert to, yes,
Yeah.
answer
Okay.
that
Fair enough.
question.
Thank you.
Mhm.
Okay. Next question from Bob. What is the state's perspective on beavers and culverts?
Yeah, that's a really good question. I mean, the challenge is that we've built a lot of our infrastructure, roads and houses and other developments in what historically were beaver wetlands. Historically beavers were all over the place. They're estimated in the, I think, millions in Vermont. They were largely extirpated, and they may have been completely extirpated from the state. So when we developed, there were no beavers here, and so beavers are recovering. We're seeing their numbers increase. And now what we're learning is that we've developed in areas that historically were beaver wetlands. And so the beavers are moving back into those places and creating these human beaver conflicts is what we call it. And so, yeah, one issue is these structures, these culverts, particularly, the smaller ones are prime areas for beavers to block, which obviously what they want to do is create a wetland, flood. And so that can cause problems upstream, in that vicinity. And that being said, beavers are ecosystem engineers, and we try and recognize them as kind of a tool in the toolbox for recovery of these systems, kind of restoring natural processes. So where it's possible to leave beavers in place, we encourage folks to do that. That being said, we recognize there's going to be conflicts where that's not possible. And there are situations where we're going to need to either mitigate. So there's ways to kind of live with beavers, but also reduce that flood risk. And so like a beaver deceiver type device might be one approach. And then, in some instances that's not possible. And so removing the beaver in the dam may be the only option. That being said, it's generally up to the municipality to determine what the best course of action is. But we do have a beaver biologist on staff who can help with that. We have included a beaver presentation into both our rivers and roads and highways and habitats training. So that's an issue that we try and address, head on through those.
Thanks, Will. So that's a perfect segue to our last question for this break. Linda was wondering, from a town perspective, is there a way to know or find out if a town road crew has participated in the rivers and roads training or the highways and habitats training? And if not, how is the sort of the best way for a CC to encourage the local road crew to participate in those training resources?
Yeah, that is an interesting question. I mean, obviously there's the ask them directly if they've done it. But if that's not possible, Stacy Pomeroy with the Department of Environmental Conservation maintains a list of attendees of the Rivers and Roads training. And Jens, I don't know if you have that information for highways and habitats.
I do. I do have the registration list of the full all the attendees for highways and habitats. And Linda, I know no one from your town has attended yet.
Yeah.
Those are all set up through the state learning management system. So your road crew has access, and that's how they access those trainings, through the LMS. And I can offline, I'll tell you more about how to do that.
Yeah. Yeah, and I'll just add, I think Jens anyway, my understanding is most of the highways and habitats trainings have been attended by Agency of Transportation staff. So I don't think very many municipalities have participated. So I think it's probably safe to assume that they haven't attended. So definitely encourage them. Specifically how to do that, that part I don't have any recommendations. Just
yeah, fair enough. Thank
yeah.
you. Okay, so we're going to jump into the next segment of the presentation, but I'll just note that Jens has posted some really useful links in the chat including a link to a YouTube presentation from Fish and Wildlife on towns and how they can manage beaver conflicts. So definitely check those out. All right, back to you, Will.
All right, great, thanks. No, great questions. Thanks, everybody. All right, let's see. So the next, I wanted to talk about riparian zones. So like I said, flooding, one of the impacts is that inundation. So, the flood zone. So this is actually a farm that the state is in the process of acquiring. This farm up in Morrisville flooded for the 7th time since the owners had lived there since 1979, and in July. And so anyway, this is this inundation is a big concern from flooding. As I mentioned earlier, erosion is a big concern from flooding. And historically, how we've tried to address it is, one way is through armoring. So, we've just armored those banks to try and prevent erosion. Again, leading to these kind of situations where you have, structures, houses right on top of the river, kind of creating that false sense of security. The other thing that happened, this is a picture actually taken after the July flood, is here a landowner cut down all their trees and then built a berm along the river, again to try and prevent floodwaters from entering, getting into their onto their property. There's some situations where a berm may be appropriate, but in general, this is something that would require working with our river engineers to figure out, when and where it's appropriate, the stream alteration engineers. Because of the risks it poses, is basically, if there's no infrastructure at risk, then we'd prefer to allow those floodwaters to access to that floodplain because of it will reduce the flooding downstream. All right. And so, here's kind of the DEC, the Department of Environmental Conservation. There's kind of like their vision of the whole river management, what we've done. So historically, these rivers they had lots of meanders. They went back and forth. And so we consider these rivers naturally stable. But like I said, over time, we've removed the material, we've channelized them, we've straightened them. And what we've done is we've created these, we've given these rivers less room to move, so less room to meander back and forth. We've also made them steeper and as a result, more powerful. So there's actually even more energy ending up in those downstream communities. As a result, they can be more destructive. And so you see examples of roads being washed out, houses being undermined, things like that. And so, people see an image like this and some people might actually see this as an uncomfortable situation. Here you've got, floodwaters, they're reaching the floodplain, and they're like, oh no, flooding, this is bad. But I would argue that this image actually is kind of what we want to see during a flood. We have no infrastructure at risk, and what those floodwaters are not really impacting anything, here. And this actually is kind of the desired outcome. This is, if we're going to have flooding, we'd like to have it look like this and not like some of those other pictures where houses are being undermined. And so this concept of allowing streams and rivers to flood the floodplain, the prime example of that in Vermont is the Otter Creek between Rutland and Middlebury. So this whole area is, it's a large wetland complex. There's a lot of ag down there, but it's also got a lot of wetland areas. And so there's a study that was done after Tropical Storm Irene, and the graph on the left shows kind of the flood response, what happened to that flood flow during Irene. And so the black line is what happened to Otter Creek in Rutland. And so that high peak, that's how high the water got in Rutland. So that flood was really concentrated into one quick event. And so as a result, Rutland just got inundated with floodwaters. And so anybody who's driven Route 4 down to Mendon, you can see that still today, just how much power there was and how much force there was. You compare that with what happened down in Middlebury, same amount of water, but because it was spread out over a longer time, you didn't have that same destructive force, right? And so, and we got to see that again this year, or last year, 2023. And this is an aerial image of a Mainville WMA in Pittsford, right on the Otter Creek. And here the Otter Creek just spilled over its banks. And this is basically what Otter Creek looked like, from Pittsburgh, Brandon, Cornwall, a bunch of these areas were inundated. And it was able to do this because we didn't really have the infrastructure. There was agriculture there, farms, but there weren't the houses and other infrastructure that was at risk. And so those floodwaters it was actually encouraged. This is an area that if we can have the flooding, have it happen here and protect those downstream communities. So that is what we saw during this 2023 and Irene. The other thing that we're encouraging folks to do is to restore forested riparian areas. So on these banks that historically have been cleared, sorry, I just want to go back. Either protect the trees if there are trees there to begin with, don't remove them, or if we can, restore them, plant them. We encourage folks to do that. And here's an example of volunteers planting actually forest parks and recreation property on the Little River up in Moscow or Stowe area. And so why do we encourage folks to restore and protect forested riparian areas? Well, obviously, fish grow on trees. Anyway, no, that's just something I like to say, and you can make a direct connection. So the fish eat the bugs, which eat the leaves, which come from the trees. So you actually can make a food web connection between fish and trees. But there's also a lot of other benefits that trees in the riparian zone provide to streams and rivers, flood resiliency, as well as fish. And so temperature moderation is one of the big ones, so that shading effect. And so what the graph is two different temperature loggers that we had out over the summer. The blue line is a forested watershed, and the red line's a largely open watershed. And there's almost a 10 to 20 degree difference in the temperature between these two watersheds. So just having that forested riparian canopy can greatly reduce the temperature. And a lot of our fish, particularly trout, brook trout, are temperature sensitive, and so they can't survive in these streams that get above 65 or 70 degrees. So they really need that cold water to persist. The other thing is we're seeing temperatures in Vermont increase. And so this is data from the National Oceanic, NOAA, National Weather Service. Anyway, going back to 1895. And so the black line, so annually the temperature fluctuates a lot. This is the mean annual temperature in Vermont going back to 1895. Annually, the temperature fluctuates a lot. The black line is the mean or the average temperature over that time span. And the blue line is just between 1999 and 2021. And there's two things to take away from that blue line. One, on average, our temperatures are much warmer now than they have been historically. Also, the temperatures are increasing, so our air temperatures are going up. As a result, we're seeing our stream temperatures increase. We've been doing, we've had temperature loggers in our streams since 1999, and we're seeing the same similar trend in those temperatures as what we're seeing in the air. So the air is driving a lot of what's happening in our streams, and so our streams are becoming less suitable habitat for our cold water species like brook trout. And then the other is that organic matter. So like I said, there's the leaves, there's bugs that eat leaves. There's also insects like ants and stuff that fall off the trees. And so this is a lot of our streams are actually fed by the terrestrial environment. It's that organic matter input. They're also habitat for a lot of birds, amphibians, reptiles, and mammals. Live in those riparian zones. Eagles are pretty cool. Herons. We'll see bats up there. People who like snakes. There's the northern water snake lives in there. We've talked about beavers and muskrats, and then wood turtles, another pretty cool species that really needs these forested riparian areas. And then there's travel corridors. So animals may not live entirely in the riparian zone, but they'll use the riparian zone to get from one place to another. And so moose, bear, and deer are examples of animals that will use these riparian zones as travel corridors, particularly forested ones. They won't really use them if they're open. And then water quality is another benefit. And so there's a pretty comprehensive review back in 2014 that looked at the buffer width, so how wide the forested buffer width was, and the water quality benefits. And what this study found is that for both nitrogen and sediment, as the buffer increased in width, the benefits increased. And what this study concluded was that about 30 meters or 100 feet was the optimum width to achieve multiple benefits for the stream. So the study looked at temperature, water quality, and a variety of other things. And so in terms of recommendations, so what's the recommended width of our riparian management zone? So what we recommend, largely based on that 2014 study, is 100 feet on each side of the stream or river. And the other important thing to point out is that it's actually almost more important on small streams to have this 100-foot riparian management zone, because those small streams are much more connected to the terrestrial environment. What happens on the landscape has a much greater impact on the aquatic system. And the other thing is, these small streams can be up to 70% of the overall stream network. And so really what we do to these smaller headwater streams has an overwhelming impact on the overall health of the aquatic system. So I've been focusing mostly on, aquatic habitat water quality. Similar things could be said for flood resiliency. A lot of that water that's ending up downstream is starting out in those headwater streams. All right, and so what can municipalities do? So the first is to adopt floodplain standards. And so this is something you can work with the Department of Environmental Conservation. They have a rivers program, river scientists, they can help with that. Adopt riparian protection standards. There's a few municipalities that have adopted those. I think that's something Jens might be able to help with. And then again, the rivers and roads and highways and habitats trainings. Both of these trainings, we discuss the riparian zone. And then again, there's more information on the Fish and Wildlife website. All right.
All right.
Okay.
Thanks again, Will. So we have one more segment coming up. Again, if you have questions, feel free to drop those in the chat. We have one quick comment from Paul. Harkening back to the beaver discussion, Paul points out that regulated trapping of beaver is another tool to mitigate human-beaver conflicts and allow harvest of a healthy and abundant resource. Thanks for that comment, Paul. I don't know if you have anything to add to that, Will? Or?
No, that's a good point. I think it's in the beaver management plan as well. There's, I think somebody might have shared it already, but there is the Fish and Wildlife Department has developed a best management practices for addressing human beaver conflicts.
Yeah. Okay, great. Thanks. All right, so we have one more segment to go, and there'll be one last opportunity for questions at the very end. So we'll continue on and wrap up before the end of the hour.
All right, great, thanks. All right, so now I want to talk about in-stream habitat and conditions, what we can do in-stream to address flooding and aquatic habitat. And so, when looking at this from a fish perspective, aquatic organism perspective, physical habitat alteration, what we've done historically to try and address flood resiliency, flood issues, we've dredged and straightened our channels. So that one image was from Gilead Brook and Bethel. We removed trees from the streams and rivers, and so that, there's an example from the Saxtons. Those are both post-Irene. And then in Bennington on the Roaring Branch, we've actually gone in and tried to create this engineered channel, and that just is, it's an attempt to simulate river processes, but what it failed to account for is the habitat element. So there's no cover, there's no structure in there, and so that's a very exposed system, and you wouldn't really find a whole lot of fish in a site like that. Turns out that approach also is not really flood resilient because streams don't like to be locked into place. They need to move around over time. And so again, what can we do in stream to work with floods rather than trying to control them? So thinking about what's happened historically and what the impacts have been to fish. So where we've gone in, people have gone in and removed material, either straightened and dredged and straightened channels, removed trees. This is after Tropical Storm Irene. The Fish and Wildlife Department did fish surveys. There's streams that we surveyed before the storm, and then after. And so what we found is that trout populations decline precipitously, 50% or more in a lot of these systems where the system was altered. So these are all examples from the White River, after a Tropical Storm Irene. And like I said, a lot of these systems still have yet to recover, and we've had to go back in and actually restore the habitat. And we'll see. Hopefully the populations will recover, but that's it's expensive. It's not guaranteed to work. Much better to leave material in place if you can. Another big, kind of counterintuitive risk, but so landslides, you actually increase the risk of landslides when you dredge a river. All right. And I want to take a minute to explain this. So when you remove that material, basically what you're doing is you're lowering the bed of the stream. And when you lower the bed of the stream, you make the banks less stable. And when you make the banks less stable, they're more likely to fail. And so even though that may be happening downstream, what ends up happening is what's called a head cut. And so that you end up, it's kind of like a domino effect. So you dredge one part of the stream, and that dredging ends up migrating upstream. So, it ends up like filling in all that material. And when that fills in, it lowers the bed upstream. And so what we find is that streams that are dredged routinely, you end up with these unstable banks, and you can actually increase erosion and landslides and kind of make problems worse, right? So now you've got even more material coming into the stream because of the dredging that has occurred historically. But after this July flood, Fish and Wildlife Department, we went out and we surveyed streams and rivers. And what we found is that areas where there was wood jams, where material was left in place, the streams were unaltered, that's where we found the fish. And so this is a section I did, and all the fish I pulled out of this stream were right under this log jam. Basically, they were, that log jam didn't move during the storm. It provided refuge from those high flows, and the fish were able to ride it out, basically. And so these log jams are important areas for fish to avoid those impacts of floods. And then here's another log jam. This is one I also took a picture of in July. And so both these pictures go together. On the left is the log jam, and you can sort of see the sediment on the bank, and on the right is more of that sediment plume. So basically what happened is this log jam reconnected the floodplain. And so that those floodwaters got blocked by that log jam, the river backed up, spilled out onto the banks. And so that water was spilling out into this forested area. So there's no risk to infrastructure or anybody. So it wasn't having a negative impact. It's also depositing a lot of sediment. And so this is, folks in the Champlain Basin may be aware of the connection between sediment and phosphorus. So a lot of our, the phosphorus is actually linked, it's actually physically connected to the sediment. And so if you have that deposition, if you have that sediment depositing on the bank, it's staying there and it's not ending up in the streams and rivers, not ending up in Lake Champlain. So this is actually a water quality benefit as well as a flood resiliency and habitat benefit. And then, like I said, we like to say fish grow on trees. And so in Vermont, the Fish and Wildlife Department, we've actually adopted a practice of putting log jams back into streams and rivers. And so we've developed what's called the Strategic Wood Addition Handbook, and this is a guideline for how to do wood addition in a way that will benefit the resource, the aquatic organisms, and water quality and flood resiliency, but also reduce risks, because we are aware that when wood mobilizes, especially when there's undersized structures, culverts and things, it can be a problem. So we have a handbook on how to do this in a way that's provides benefits, also reduces risks. The other thing, we've been doing this since 2012, and our biologists have gone back, resurveyed some of these wood addition sites, and we've seen that this wood addition has increased biomass of brook trout up to 300%. So we're seeing a huge increase in production because of these wood structures. And so they're providing refuge not only from floods, but also areas for fish to hide from predators and for feeding. They create these pools that the fish really like. And so it's just another example of how fish grow on trees. And the concern is the undersized infrastructure. So what happens when you have wood in these streams that are under with smaller culverts? And like I said before, what we found is that structures that were sized to standards did not have the wood accumulating. And so when we develop our install our structures to bank full width standard, that reduces the risks. I'm not saying that we should go in and put wood everywhere, but we still need to be cognizant of that risk. But it seems to be, at least, that the risk is lower when we have these 1 times bank full width culverts. And then there's some situations where that's not possible, and we have seen additional strategies, such as these kind of wood racks, to try and accumulate material and keep it from getting into the culvert, blocking up the culvert. All right, and so what can municipalities do? So follow stream alteration standards for wood removal. So basically, if you don't need to remove it, if there's no threat to human health and safety, we encourage folks to leave the trees in the stream and river. And again, work with the stream alteration engineer, the DEC program. We work with them a lot to kind of develop these standards and make recommendations for municipalities. All right. And so just want to wrap up. I'm noticing that the time, it's already, I just want to, so in conclusion, what first point is, we recognize that flooding is going to happen. We're a mountainous state. It's getting more humid. We're seeing more water, more precipitation. We're unfortunately in a situation where we anticipate that we're going to continue to see floods, and that those floods could get worse. What we're recommending is, if we can learn to live with flooding rather than trying to prevent it or mitigate it, it'll be better for both people and fish. We can increase flood resiliency and aquatic habitat by restoring these natural processes. And so today we learned about 3 areas that municipalities can do to increase flood resilience and aquatic habitat. So fish-friendly culverts, forested riparian areas, and in-stream log jams where it is safe to do so. And with that, just want to present thank everybody for attending. And here's a contact for me and Jens if you have any more questions. Thank you.
Yeah, thank you so much, Will. That was fantastic. So
sure.
We have let's see, there's a little bit of additional conversation on beaver. I'd recommend those folks, encourage you to watch the webinar focus on beaver, or we can connect you with beaver biologist. But since we're short on time, I want to jump to a question that's focused really on the stream management here from Bob. So do the habitat value benefits of wood additions apply to streams that are too warm to support brook trout?
Oh, definitely. Yeah. I mean, all like even Otter Creek, there's a lot of other species that benefit from the wood in there. And that's a warm water stream, and so we have northern pike and bass and things like that. So yes, no, it's pretty universal. And there's other animals besides fish that use log jams, like muskrats and things, and birds obviously like to perch on them and eat fish. So yeah, no, they have lots of benefits.
Great. Let's Let's see. I think that is actually our last question
Okay.
here. So we'll wrap things up, and we'll thank everybody for coming out today. This is fantastic. Thank you, Will. Jens, do you have any concluding comments? Jens or Will?
No, Linda and Chris, I just wanted to flag for you that piece in the chat about the rivers and roads and highways and habitats, and how there's how road crews learn about those trainings is through the VTrans Training Center. But the Tier 1 version of both of those trainings is available to municipal road crews at any time. And so I included the page for the state learning management system. That's just the login page. It's not going to make sense to you all. It will make sense to the road crew foremen who have a login to that learning management system. So I just wanted to flag that for folks. But Will, thank you so much. This was really excellent. Really appreciate it.
Thanks, everybody. All right. All right. Yeah, and feel free to reach out if you have any more questions.